Okay, we're going to talk about how Git hashing actually works under the hood. So let's get into it. You all know how to type git log and see your hash or your SHA. The D9EA, that's a 40 character hexadecimal digest. That's the result of the SHA1 hashing algorithm, the SHA1 algorithm, which Git uses by default. And this right here is a type of object called a commit object. As the name implies, it's commit D9EA. And where these are stored, if you go into the hidden directory here, oops, I didn't mean to type git period, I meant to type vim period, and go into .git and objects, you're going to see the D9EA, and this is what it is, it's compressed, but the address of the file is the content going through the hashing algorithm. And that's actually why Git is known as a content addressable file system, because the files and the directories to get to those files is actually the content that's ran through this hashing algorithm, which serves as a checksum, because if anything changed in the files, then the hashing would not produce that same output. So let's put that to the test. Let's run the contents of these files through the same SHA1 algorithm and see if it produces these same checksums here, because we're, for some reason, I guess, suspicious that somebody changed our files in our Git repository. So the first thing we're going to do, if I do git log, is we're going to grab that SHA, D9EA, and that's all I need. I'm going to use the first 4 characters because it's easy to remember. So D9EA, and we're going to use a Git command called cat file. Now, this is a command that probably the majority of Git users don't know about. And I guess if you're just someone that likes to look into the internals of Git, you know about it, but it's not really useful unless you just want to know how Git works. So git cat file, I'm going to give it a -p flag, which stands for pretty print. What's kind of interesting about this command is you have to give it a flag. If you don't give it anything, it's just going to throw an error or give you actually the help page. And so I'm going to do I think it's D9EA, and I was going to show you the error. So yeah, or it's not an error, but it basically says, oh yeah, it is an error. Fatal, only 2 arguments allowed. So we're going to do git cat file -p D9 EA. So those are the first 4 characters of that commit SHA there. Let's type enter, and there we've got it. All right, we've pre-printed it. So remember how the content was all compressed and it was just those random bytes that we didn't know what they were. They didn't produce any ASCII characters, but now we have allowed Git to decompress the file and we can see what the file contains. And this commit object contains other objects. And as you can see, it has one tree object. So let's do the exact same command again, git cat file -p, and let's do EC94. So that's the first 4 characters of this one right here. So we're just going to dig a little deeper here. So there it is. This one is the tree object, and it contains 1 blob object. So in Git, you can hash 4 types of objects: commits, trees, blobs, and tags. And so commits contain trees, which are like directories. Trees contain files, which Git calls blobs. And so then we can do git cat file -p, pretty print AF56. Other way, 56. All right, hello world. So that is what our commit contained. That was the file. And if I do ls, we can see that was what was committed. If I cat hello.txt, there were the contents. So that's really cool. So if I do git period, keep typing that, vim period, and go into .git and go into objects, we can see our 3 directories, AF, D9, EC. Those are those 3 objects. And so I don't remember which ones were which, but there they are. And so let's take our file, that blob, hello world, and let's run it through the SHA1 algorithm and see if it produces the same checksum there. So the first thing I need to do is go up a little bit, and I'm going to do this one. So there was our commit, the AF56 one, that's the blob, inside the tree one, which is EC94. So I would expect to run hello world through, because if I do this one here, it's hello world. So I would expect if I run that text, hello, comma, space, world, exclamation point, through the SHA1 algorithm, I would get the same checksum, AF56, etc. So let's see. So I'm going to pipe it into this SHA-1 command, hit enter, and 09FAC8D. Oh man, that is not the same at all. Did someone like mess with our file? Man, these checksums aren't lining up. And if you've decided to actually put Git to the test and be like, do these checksums actually check the sums? You maybe have ran into this and you're like, well, they're different. So what in the world is going on? They're both using the SHA-1 algorithm, right? They are. And here's what's happening. In the Git source code, when it runs these blobs through the SHA-1 algorithm, before it does that, it doesn't just take the content. It actually builds a header. And the header contains the type, which in this case is blob, and then a space, and then an integer, which is the number of bytes in the file, and then the null character, and then the contents of the file. So that would be nice to know, right? So let's try it. So echo, and let's do blob space, and let's count the bytes in it. 1, 2, 3, 4, 5, 6, space, so 7, 8, 9, 10, 11, 12, 13. So we'll do hello world. Oh, no, excuse me, 13. And then we're going to do a null character. That's going to be \u 0000. And then we're going to say hello world, SHA-1, and cross your fingers. Oh man, still didn't work. And some of you are probably frustrated watching this. You're like, there's more than 13 bytes in that because of the new line character, actually. So if I actually cat the file, let's do the hello text file, I'm going to feed it into this hex dump utility here. We can see the total number of bytes are here. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then this bottom number actually shows us the number. And that E in hexadecimal is 14. Hexadecimal goes 0 through F. And so F is 15. And so E, one less than that, is 14. So we got 14 bytes. And the reason for it is these actually go, the one on the right comes in first. So the 48 is actually the capital H. The 65 is the E. 6C is the LL. So if we go to the end here, that means the 21 is the second to last character, which is the exclamation point. OA in the ASCII encoding is a new line character. So there are actually 14 characters. We just only see 13. So this is a simple fix. So let's go up again a few times, and let's change that 13 to a 14. Now, I really do expect this to work. So if it doesn't, I'm going to be very disappointed. AF56, oh, great, perfect. And if I take that and say git cat file -p, copy it all in there, we got hello world. Excellent. So the checksums worked. We know no one's messed with our file. The content addressable file system showed us the content and the address being the content that ran through that hashing algorithm. There's a few more things you can do. So what you can do is you can say echo hello world, and then pipe that into the git hash object command. Oops. And give it the standard input flag. That means it's going to take whatever's piped into it. If you don't, it would expect like a file to be the argument, and it's going to produce the exact same thing. And you can supply other flags to actually let it write to the database there, the content addressable file system, if you choose to do so. But so you can cat files. That means you can see what your hashes actually contain. They could be commits, they could be trees, they could be blobs, they could be tags. You can use git hash object, and then that's how you build the header. So you got to give it the type. For blobs, a type blob, and then the number of bytes, the null character, which is \u 0000. By the way, null character is literally just 0, no ones in the byte at all. That's the null character, the null byte, I should say. So that's it. That's really how Git works, and that's how you can actually test that it's hashing it properly. So thanks for watching.